Yeah, recorded rolling. I got a story for you guys called The Fermi Paradox. This is an essay by Tim Urban. I think it's about 12 something years old. Everyone feels something where they're in a really good starry place on a really good starry night. They look up and they see this. Whoa. Some people stick with their traditional feeling struck by epic beauty or blown away by the insane scale of the universe. Personally, I go for the old existential meltdown followed by acting weird for the next half hour. But everyone feels something. Uh, have you guys ever, here, guys, show of hands, who's ever been out where there's basically no light pollution? You guys ever been out, maybe way out west, possibly? Yeah, yeah, somewhere? Yeah, yeah. Yeah, you can see like a lot more stars. Something I noticed too, I was in Arizona a year ago, and yeah, you can see like satellites all over the place that you can't really see so much in Florida because there's so much light pollution here. Physicist Enrico Fermi felt something too. He asked the question, "Where is everybody?" Now, Enrico Fermi, he's one of these scientists who worked on Manhattan Project, create nuclear bomb. He worked on particle physics, quantum mechanics. So he's done a lot of important things. But yeah, he's also known for this particular question that, according to lore, he just happened to mention just in passing at lunch once, and then yeah, the story's kind of handed down from there. A really starry sky seems vast, but all we're looking at is our very local neighborhood. On the very best nights, all we can see is up to about 2,500 stars. There you go. There's a picture for you guys. Roughly 100 millionth of the stars in our galaxy, and almost all of them are less than 1,000 light years away from us, or 1% of the diameter of the Milky Way galaxy. So when you guys look up and you see all the stars and all the constellations, and you say, "Oh, there's the North Star," and there's the Seven Sisters, and there's Orion. It's all inside that red circle there. Okay, yeah, as if we were able to see down and see the Milky Way from that perspective. It would all be inside that little red circle. When confronted with the topic of stars and galaxies, a question that tantalizes most humans is there other intelligent life out there? So let's put some numbers to it. Right now, the next few paragraphs is going to basically go through something called the Drake equation. And this is also how Fermi framed this. Right? How Enrico framed it here, I'll tell you guys a little bit different story, but it's kind of related to this thought process. When the first atomic weapons were being tested in about New Mexico in the 1940s, they need to know, well, how big is this explosion going to be, basically, right? And they could do the theoretical physics calculations beforehand, just to get a ballpark idea. Right? And what he would do is, as the nuclear blast wave was coming across, they're way up, probably several miles in the back, watching this, right? He would drop little pieces of paper and watch them flutter to the ground. And if he knew the mass of the paper and the area of the paper and something about viscosity of air and the gravity field of the planet, he puts all these variables together. And of course, the papers don't fall straight down; they follow the blast wave and land off a little bit to the side. He was able to come up with a pretty good estimate of how big that blast was, so many miles away. Right? So he's taking quantities that you can know, and he's getting a good ballpark estimate of something that's a little bit harder to pin down. Right? And that's the thought process we're about to apply here. So as many stars. So back to the essay here. As many stars as there are in our galaxy, somewhere between 100 billion and 400 billion, there are roughly an equal number of galaxies in the observable universe. That's to say, for every star in our Milky Way galaxy, over 100 billion, there's another whole galaxy out there. Altogether, that comes out somewhere between 10 to the power 22 to 10 to the power 24 total stars, which means that for every grain of sand on Earth, there are 10,000 stars out there in the observable universe. The science world is not in total agreement about what percentage of those stars are sun-like. Similar in size, temperature, luminosity, opinions range somewhere between 5 and 20%. Let's go with the more conservative side of 5% and the lower end number of stars, 10 to the 22. Multiply those together. That gives you 500 billion sun-like stars. There's also the debate of what percentage of those sun-like stars might be orbited by an Earth-like planet, one with similar conditions to Earth, have liquid water, potentially be able to support life. Some say it's as high as 50%, but let's go with the more conservative 22%. It came out of a recent PNAS study. Okay, so multiply those numbers together. That suggests that there's a potentially habitable Earth-like planet orbiting at least 1% of the total stars in the universe. total 100 billion Earth-like planets. So there are 100 Earth-like planets approximately for every grain of sand in the world. Think about that next time you're on the beach. Moving forward, we have no choice but to get completely speculative. Now, I should have looked this up before, but I'm gonna get a search for you guys real fast. Let me look up because I want to give you guys something to look up. Look out here. Drake equation. We did a little search here. All right. Because this is really how this is all being. Okay, the internet's kind of slow, but I'll just wait for that pop up. Uh, we have no choice but to get speculative. So the numbers so far, we have some observations and kind of some hard number estimates for. Let's imagine that after a billion years of Earth's existence. Oh, guys, how old is the Earth, by the way? How old is the Earth? It's about 4.5 billion years old. There's some reasons they know that, but so let's go 4.5 billion years. How old is the universe? Yeah, about 14 billion some years old. Plus or minus a little bit. So 4 billion some years for the Earth, 14 billion about for the universe. Right. So 4 versus 14. Right. So just in the lifetime that our own planet has had, there's been like opportunities for several lifetimes of other planets to come and go. All right, here we go. Yeah. You guys see this equation right here? Right. So basically, we're going down this line saying, okay, well, how many stars are out there? How many are orbited by a planet? How many of those planets are Earth-like? How many? How many? How many? We're getting all these ratios. We're going to multiply all these ratios together to get an estimate of. This is where this is all headed. How many extraterrestrial civilizations should we be in communication with by now? Right. That's where this question is all heading. Okay. Okay. Put this back up here for you guys to. Um, let's imagine that 1% of planets develop life, and out of all Earth-like planets, 1% develop life, and out of those 1% that develop life, let's imagine that 1% of those, the life advances to an intelligent level, like it does on Earth, where we have technology and so on. That would mean that there are 10 quadrillion or 10 million billion intelligent civilizations in the observable universe. Now, observable universe is pretty big. So next paragraph, I'm really glad it goes back to just our galaxy. So let's just stick to the Milky Way for the rest of this. Uh, let's go back to the galaxy, do the same math, the same estimates, the same blah, 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 percentage. Right? Right. We would estimate that just in the Milky Way galaxy, there should be 1 billion Earth-like planets and 100,000 intelligent civilizations just in the Milky Way. SETI, which stands for Search for Extraterrestrial Intelligence, is an organization dedicated to listening for signals from other intelligent life. If we're right that there are 100,000 or more intelligent civilizations in our galaxy, and even a fraction of those are sending radio waves or laser beams or other kind of modes attempting to contact others, shouldn't SETI's satellite array pick up all kinds of signals? But it hasn't, ever. So where is everybody? It gets stranger. Our sun is relatively young in the lifespan of the universe. There are far older stars with far older Earth-like planets, which should mean, in theory, civilizations far more advanced than our own. As an example, let's compare our 4.5 billion-year-old planet Earth to a hypothetical 8 billion-year-old planet X. Right, so yeah, we can just scoot around billions of years in the big scheme of things. If planet X has a story that's similar to Earth, let's look at where their civilization would be today. Okay, and then some other. The technology and knowledge of a civilization only 1,000 years ahead of us. Okay, yeah. So pause and think about that for a moment. Like, what is the technology even going to look like by the end of the century? Could be crazy. In 1,000 years out, right? Yeah, assuming we're still alive, could be as shocking to our world as our world would be to a medieval person. A civilization 1 million years ahead of us might be as incomprehensible as human culture is to chimpanzees, and this planet X is some 3 billion years ahead of us. And it's just hypothetical, but there's plenty of time enough for this, right? There's plenty of space and plenty of time, right? That's 2 dimensions. They work on just how crazy big the universe is, right? It's not just in size, but also it's super old. There's something called the Kardashev scale, which helps us group intelligent civilizations into 3 broad categories according to the amount of energy they use. A Type 1 civilization has the ability to use all the energy on their planet. We're not quite a Type 1 yet, but we're maybe close. One estimate puts us at maybe a 0.7. A Type 2 civilization can harness all the energy of their host star, We might hardly be able to imagine how someone would be able to do this, but we've tried our best imagining things like a Dyson sphere, which might be a sphere like a shell, or maybe it could just be like billions of little satellites going around the sun and capturing solar energy and beaming that back to the home base or Earth. Right? A Type 3 civilization would blow the other two away, accessing comparable to that of the entire galaxy. If this level of advancement sounds hard to believe, remember that hypothetical Planet X and their 3 billion years head start on development. If a civilization on that Planet X were similar to ours and were able to survive all the way to Type 3, the natural thought is they probably have mastered interstellar travel by now, possibly even colonizing the entire galaxy. And now, how could that happen? Because I just said the galaxy is really big, right? Well, one hypothesis as to how galactic colonization could happen is by creating machinery that can travel to other planets, spend, 500 years or so 5 centuries, self-replicating using the raw materials on that new planet, sending off two replicas to do the same thing, even without traveling anywhere near light speed. This process of go to a new planet, spend 500 years there, two probes, next planet's 500 years, two probes, and so on, because of how exponential growth works, could colonize the entire Milky Way galaxy in 3.75 million years. So less than 4 million years? That's a relative blink of an eye when talking about the scale of billions of years. Right? Like, what is a billion compared to a million? Well, that's like 1,000 millions, right? And so like this. Right? Oh yeah, there's your visual for like branching off and just doing two at a time. Continuing to speculate, if 1% of intelligent life survives long enough to become a potentially galaxy colonizing Type 3 civilization, our calculations above, all those estimates in the Drake equation above, suggest that there should be at least 1,000 of these Type 3 civilizations in our galaxy alone. And given the power of such a civilization, their presence would likely be pretty noticeable. And yet, we see nothing, hear nothing, we're visited by no one. So where is everybody? And just to reiterate, I know I said this before, but this was published, I think, in 2014. So if something sounds a little bit dated, that might be why. But I'm just going by this essay here. So where is everybody? Welcome to the Fermi Paradox. We have no answer to the Fermi Paradox. The best we can do is possible explanations. And if you ask 10 different scientists what is their hunch about what's the correct one, you'll get 10 different answers. When you hear humans of the past debating about whether Earth was round or whether the sun revolved around Earth, or thinking that lightning happened because of Zeus, and that all seems so primitive and in the dark, that's about where we are with this topic. And taking a look at some of the most discussed possible explanations of the Fermi paradox, let's divide them into two broad categories. Type 1, explanation group 1 are explanations that assume that there's no sign of higher level civilizations because there are none of them out there. And then later on, and there's a whole subcategory list of those. Okay? Right. And then later on, we'll get to explanation group 2, which assumes that they are out there, but we might not be seeing or hearing from them for other reasons. So starting with explanation group 1, there are no signs of higher civilizations because none of them are in existence. Those who subscribe to group 1 explanations point to something called the non-exclusivity problem, which rebuffs any theory that says there are higher civilizations, but none of them have made any contact with us because they all fill in the blank, whatever that blank is. Group 1 people look at the math, which shows that there should be so many thousands or more of these civilizations out there. At least one of them would be an exception to the rule. Even if some theory held for 99.99% of higher civilizations, the other 0.01% would behave differently, we would become aware of their existence. Therefore, say group 1 explanations, it must be that there are no super advanced civilizations. Since the math suggests that there should be thousands of these highly intelligent civilizations just in the Milky Way galaxy, something else must be going on. That something else is called the Great Filter. Dun, dun, dun. The Great Filter theory says that at some point, from pre-life to Type 3 intelligence, there is a wall that all or nearly all attempts at life hit. There's some stage in that long evolutionary process that is extremely unlikely or impossible to get beyond. The stage is called the Great Filter. If this theory is true, the big question is, where in the timeline does this Great Filter occur? It turns out that when it comes to the fate of humankind, this question is very important. Depending on where the Great Filter occurs, we have we're left with three possibilities. We're rare, we're first, or we are headed for inevitable disaster. So let's start with subcategory one. We're rare. That's to say the great filter is behind us. One hope we have is that this great filter is behind us. We've managed to surpass it, which would mean it's extremely rare, perhaps to get to our level of civilization. That diagram shows maybe only two species making it past, and we're one of them. The scenario would explain why there are no Type 3 civilizations, but it would also mean that we could be one of the few exceptions now that we've made it this far. It would mean that we have hope. On the surface, this could sound a bit like people 500 years ago suggesting that Earth is the center of the universe. It implies that we're special. However, something scientists call the observation selection effect suggests that anyone who is pondering their own rarity is inherently part of an intelligent life success story. Whether they're actually rare or quite common, the thoughts they ponder and conclusions they draw will be identical. This forces us to admit that being special is at least a possibility. And if we are special, when exactly did we become special? Which step did we surpass that almost everyone else gets stuck on? One possibility is the great filter could be at the very beginning. It might be incredibly unusual for life to begin at all. This has to be a candidate because it took a billion years of Earth's existence to finally happen, for life to finally start. And we have tried extensively to replicate that event in labs. We have never been able to create artificial life in labs, like with biology and RNA or DNA. Never been able to do it. They've been able to create like I think amino acids or something, but not anything that's alive and replicates. If this is indeed the great filter, it would mean that not only is there no intelligent life out there, there might not be any other life at all. Another possibility, maybe the great filter could be the jump from simple prokaryote cell to complex eukaryote cell. Do you guys remember from biology? Actually, you guys probably remember better than I do. You actually have two sets of DNA in every cell, right? There's mitochondrial DNA, and then there's what do they call the other DNA? I'm sure there's a name for it. Well, anyway, right, you got these two sets, right? And the thought is right now nobody knows for sure, right? But I think the leading idea is that about two some billion years ago, probably two simple prokaryotes, like two simple type bacteria, merged, but instead of one digesting the other, they actually existed symbiotically, and that's why to this day, all large life, except for some simple bacteria, has this this dual system of uh, uh, DNA, right? And that's eukaryotic life. Uh, After prokaryotes came into being, they remained that way for almost 2 billion years before making the evolutionary jump to being complex and having a nucleus. Uh, there were 2 billion years of Earth's existence where there was life, but it was all just very simple bacteria just hanging out in the oceans. And that was it for like 2 billion years of just simple bacteria in the ocean. There was no plants, no animals, nothing like that. Uh, if this is the great filter, it would mean that maybe the universe is teeming with simple prokaryote life and nothing beyond that. There are a number of other possibilities. Some even think the most recent leap we've made to our current intelligence and civilization is a great filter candidate. While the leap from semi-intelligent life to intelligent life, say from chimps to humans, might not at first seem like a miraculous step, Steven Pinker rejects the idea of an inevitable climb upward of evolution. Evolution does not strive for a goal, but just happens. It uses adaptation most useful for a given ecological niche. The fact that on Earth, this led to technological intelligence only once so far may suggest that this outcome of natural selection is rare and hence by no means a certain development of the evolution of a tree of life. And you guys might know some more nuances to this too. Yeah, so there are other animals that can use some basic tools. You guys are probably seeing crows and like chimpanzees, right? But are there any other animals actually like writing this down, like that have communication to the point that they can have writing and pass forward and like build on their technologies? Well, only humans we know so far. Most leaps do not qualify as great filter candidates. Any great filter must be a one in a billion type thing where one or more total freak occurrences need to happen to provide a crazy exception. For that reason, something like the jump from single cell to multicellular life is ruled out because it's happened as many as 46 times. This planet alone. Maybe I skip a little bit here. Oh, wait. No, I do want to read this. For the same reason, if we were to find fossilized eukaryote cell on Mars, it would rule out the above simple to complex cell leap for the Great Filter. Because if something happened on both Earth and Mars, it would definitely not be a 1 in a billion freak occurrence. If we are indeed rare, it could be because of a fluky biological event, but it could also be attributed to what's called rare Earth hypothesis, which suggests that there may be many Earth-like planets, but maybe the particular conditions on Earth, whether it's related to specifics of our solar system, relationship with our moon, maybe have a Jupiter out there, vacuum up a bunch of asteroids, maybe exactly how much water we have, maybe something about our atmospheric composition. Maybe there's something that's exceptionally friendly to life that maybe we might be even taken for granted. We're just kind of looking past. Right, so possibility two. Maybe we're the first. We're the first. Is this the right? Okay. For group one thinkers, if the Great Filter is not behind us, one hope that we have is that the conditions in the universe are just recently, for the first time since the Big Bang, reaching a place that would allow intelligent life to develop. In this case, we and many other species may be on our way to superintelligence, but it simply hasn't happened yet. We happen to be at the right place at the right time to become one of the first superintelligent civilizations. One example of a phenomenon that could make this realistic is the prevalence of gamma ray bursts, insanely huge explosions that we've observed in distant galaxies. In the same way that it took early Earth a few 100 million years before the asteroids and volcanoes died down and life could even become possible, it could be that the first chunk of the universe's existence was full of these cataclysmic events like gamma ray bursts that would incinerate everything nearby from time to time and prevent life from developing past any certain stage. Now perhaps we're in the midst of an after-biological phase transition, and this could be the first time life has been able to evolve this long uninterrupted. Possibility three, maybe we're headed for inevitable disaster. That's to say, the Great Filter is ahead of us. If we are neither rare nor early, Group 1 thinkers conclude that the Great Filter must be in our future. This would suggest that life does regularly evolve to where we are, but that something is preventing life from getting much further and reaching high intelligence in almost all cases, in which case we are unlikely to be an exception. One possible great filter, future great filter, is a regularly occurring cataclysmic natural event, like the aforementioned gamma ray burst, except unfortunately they're not done yet. It's just a matter of time before all life on Earth is suddenly wiped out by one. Could be something natural, it could be a virus, could be who knows, right? Another candidate is the possible inevitability that nearly all intelligent civilizations end up destroying themselves once a certain level of technology is reached. This is why Oxford University philosopher Nick Bostrom says that, quote, no news is good news. The discovery of even simple life on Mars would be devastating because it would cut out a number of potential great filters behind us. And if we were to find fossilized, complex life on Mars, Bostrom says that, quote, it would be by far the worst news ever printed on a newspaper cover, because it would mean that the Great Filter is almost definitely ahead of us, ultimately dooming our entire species. Bostrom believes that when it comes to the Fermi Paradox, the silence of the night sky is golden. All right, so that was all explanation group one. Let's go to explanation group two. And then there's a whole subcategory of lists under this. Type 2 and 3 civilizations are out there, but there might be reasons that we're not hearing from them. Group 2 explanations get rid of any notion that we're rare or special or the first in anything. On the contrary, they believe in the mediocrity principle, whose starting point is that there is nothing unusual or rare about our galaxy, solar system, planet, civilization, until evidence proves otherwise. They're also much less quick to assume that the lack of evidence of higher intelligence beings is evidence of their non-existence, emphasizing the fact that our search for signals stretches only 100 light years away from its 0.1% across the galaxy. And so back to that picture again. And suggesting a number of possible explanations. Here are 10. Now, I think we have about 5 minutes, so I'll just read the headlines and then there's more details here. But right. Possibility 1. Super intelligent life could very well have already visited Earth, but long before we were here, maybe some tens of thousands of years ago, and maybe they just never came back. Possibility 2. The galaxy has been colonized, but maybe we just live in some desolate rural area of the galaxy. And maybe I think we are kind of like way out there. Maybe all the action is maybe like over here, and nobody wants to come out here or something. Possibility 3. maybe the entire concept of physical colonization is a backward concept to a more advanced species. And the details it goes into here is like, well, maybe civilizations at some point, maybe the individuals want to upload their consciousness to some kind of computer system and just live there rather than the physical world. Possibility four, maybe there are scary predator civilizations out there, and most intelligent life knows better than to broadcast any outgoing signals and advertise their location. Possibility five, which is actually pretty similar, maybe there's only one instance of higher level intelligence, a super predator civilization who is far more advanced than everyone and actively keeps it that way by exterminating any intelligent civilization once they get past a certain level. Possibility six, maybe there is plenty of activity and noise out there, but our technology is too primitive or we're listening for the wrong things. Possibility seven, maybe we are receiving contact from other intelligent life, but the government is hiding it. Possibility eight, maybe higher civilizations are aware of us and observing us, also known as the zoo hypothesis. So maybe they're watching us, but don't touch, don't interact with the humans. Possibility nine, higher civilizations are here all around us, but we're too primitive to perceive them. Possibility 10, maybe we're completely wrong about our entire reality at all. There could be ways that we're just totally off about the way we think. The universe might appear one way and be something else, like a hologram. Maybe, yeah, it goes through some possibilities there, right? We have the senses we have. We can understand space and time the way we understand it, but maybe there's another dimension we don't have access to sense it, right? Okay, so that's a whole list of possibilities, right? And then he goes into his concluding paragraphs. I skipped a bunch of details on those possibilities. Right? As we continue along with our possibly futile search for extraterrestrial intelligence, I'm not really sure what I'm rooting for. Frankly, learning that we are officially alone in the universe or officially joined by others would be creepy, which is a theme with all the surreal storylines listed above. Whatever the truth actually is, it's mind-blowing. Beyond its shocking science fiction component, the Fermi Paradox also leaves me with a deep humbling, not just the normal, oh yeah, I'm microscopic and my existence lasts for 3 seconds humbling that the universe always triggers. The Fermi Paradox brings out a sharper, more personal humbling, one that can only happen after spending hours of research, hearing people's most renowned scientists present insane theories, change their minds again and again, wildly contradict each other, reminding us that future generations will look at us the same way that we look at ancient people who were sure that stars were on the underside of a dome of heaven and think, wow, they really had no idea what was going on. Compounding all this is the blow to our species' self-esteem when it comes with all this talk of type 2 and 3 civilizations. Here on Earth, we are the king of our little castle, proud ruler of all the people who share this planet with us. And in this bubble with no competition and no one to judge us, it's rare that we're ever confronted with the concept of being dramatically, technologically inferior to anyone else. But after spending a lot of time with these type 2 and 3 civilizations, our power and pride might seem a bit overestimated. That said, given that my normal outlook is that humanity is a lonely orphan on a tiny rock in the middle of a desolate universe, the humbling fact that we're probably not as smart as we think we are, and the possibility that a lot of what we're sure about might be wrong, sounds wonderful. It opens a door just to crack that maybe, just maybe, there might be more to the story than we realize.